All right, in this video, we're looking at limiting reactants. And what those basically are is we acknowledge that if I want to make this product, it's not enough just to have 30 moles of Na. Like, sure, I could figure out what 30 moles of Na could produce, but it takes both chemicals to actually make the product. So the idea is you could run out of one before the other. It's like if I had enough bread to make 5 sandwiches, but only enough peanut butter to make 3, then I'm only going to be able to make 3 sandwiches. So the idea is something is limiting you. And there's a couple ways to do limiting reactants. Some of you have, there's another method called using an ice chart, which is a way to organize. But the other way is just to do 2 stoichiometry problems. So in this case, I'm trying to figure out how much of this product I'm going to make, and I'm given 2 separate amounts of reactants. And all you do is just treat each one separately. So you start with the Na and say, okay, let's say I have 30 moles of Na. If pretend oxygen was no object, I had as much of it as I wanted, how much Na2O could I make? And we just look at the ratio. It's 4 to 2. So in other words, for every 4 moles of sodium, I can make 2 moles of Na2O. And I just multiply that out, and I could make 15 moles. So basically, I have enough sodium to make 15 moles, assuming I have plenty of oxygen. Then I do the problem again with the oxygen. I say, okay, great. What if I had 20 moles of oxygen? How much NaO2O could I make? So I look at that ratio. This is a 1 to 2 ratio. So for every 1 mole of O2, I can make 2 moles of Na2O. 20 times 2, I get 40. So basically, there is enough sodium to make 15. There's enough oxygen to make 40. But you need both ingredients to do this, so you're only going to make 15. So we say that sodium is our limiting reactant. It's holding us back. And we say oxygen is our excess reactant. We have leftovers of it. And that's how we do a limiting reactant problem. Now, you might also be asked how much oxygen is left over. And we could figure that out if we wanted to. What we would do is say, okay, if all the sodium reacted, how much oxygen would it need? And so we look and say it's a 4 to 1 ratio. So for every 4 moles of sodium, I need 1 mole of oxygen. And so I can multiply that out. I get 30 times 1/4. And if I do that, I get 7.5 moles of O2. So that means this reaction is going to consume 7.5 moles of O2. There were 20 moles available. So what's left over? 20 minus 7.5. There's 12.5 moles of oxygen left. So that sometimes is asked as a question. If you're using the ice chart method, it's all solved within the chart. But if you're doing this method, you might have to do an extra calculation after. But bottom line, a limiting reactant problem, you're just doing the problem twice. Regular stoich problem. Let's look at one other. So here's another limiting reactant problem. And again, the way you can tell it's a limiting reactant problem is they typically are giving you both chemicals. Whereas a lot of stoichiometry problems, they just give you one and say, how much can you make? Here, they're giving us both. So we're trying to figure out how much water we can make. And we're told we have 50 grams of this and 70 grams of this. So we have to treat each one separately. Let's start with the 50 grams of C2H6. So I want to go from here to here. And I notice I'm in grams, so I can't go direct. I have to follow, go back and watch the other stoich problems if you're not sure. But I'm going to start by converting this to moles. So I need to look up the molar mass of C2H6. If I add it up, it's about 30.08. So there are 30.08 grams of C2H6 for every 1 mole of C2H6. And then the ratio is 2 moles of this to 6 moles of water. So for every 2 moles of C2H6, there are 6 moles of water. And it's asking for grams of water, so I need to say, okay, I'm in moles of water. For every mole of water, there are 18.02 grams of water. So I know I did that kind of fast. You got to really make sure you understand regular stoichiometry problems before you really dive into this too deeply. But anyway, so I'm going to go 50 times 1 divided by 30. You might want to just multiply all the top numbers and then all the bottom numbers and divide. But either way, if you've done this properly, I get 89.86 grams of water. So there is enough C2H6 to make this much water. And then just repeat the problem with the oxygen. Okay, so 70 grams of oxygen. I first have to convert it to moles. So there's 32 grams of oxygen for every 1 mole of oxygen. The ratio is every 7 moles of oxygen makes 6 moles of water. And then every 1 mole of water is 18.02 grams of water. Okay, so if I multiply all of that, this is from the previous one. So I got 70 divided by 32 times 6 divided by 7 times 18.02. I get 33.79 grams of water. So again, I know I'm doing this fast, but go back and look. There's enough of this chemical to make this much water. There's enough oxygen to make this much water. So how much do we make? It's always the smaller one. So we make the smaller quantity of water, which means oxygen is your limiting reactant, C2H6 is your excess reactant, and that's how you approach a limiting reactant problem, which is basically stoichiometry problem done twice or 3 times if you have 3 reactants. That sometimes comes up. So that's it. Until next time, I am Derek Genova. Have a delightful day.